All right, here we're dealing with applications. So what do we have? It has, after withdrawing $125 from his account, Alan finds he's overdrawn by $15. All right, what was his account balance before the withdrawal? So now we kind of have to think about what we want to do. Well, first off, we have to, determine a variable. So the variable is usually what they're asking for. What was his account balance before the withdrawal? So I'm going to call that one, and if it'll give me my drawer, it might, nope, and now it will. That's going to say X equals account balance. Okay, so now what we're going to do is write that based on what's written here. So after withdrawing $125 from his account, Alan finds he is overdrawn by $15. What was his account balance before the withdrawal? Well, we're going to say, oh, that's going to be X minus 125 equals. Now, if you're overdrawn by $15, what's that give you? Well, that gives you a negative $15. But since our equation, we're not going to put any units, that's just going to be a negative 15. So that's our equation we have to solve. Well, we know how to do that. We'll just add 125 to both sides. Now, it might be easier if you take 125 minus 15 with a larger number on top than with it like this. So 5 minus 5 is 0, 2 minus 1 is 1, 1 minus 0 is 1. So X equals, now that's $110. Now, does that make sense with the whole problem we had? Well, if we take 110 minus 125, does that equal a negative? Oops, I only need one of those negatives there. Does that equal a negative 15? Well, what we're going to have to do is take the larger, which is 125, minus the smaller, which is 110. So that's 5, that's 1, that's 15. The larger one was negative, so it's negative $15. So that does check out as the original balance. All right, so a student's bank account is overdrawn. So he already knows it's overdrawn. And then he's going to make a deposit of $300 and finds his account is still overdrawn by an amount of $70. What was his balance before he made his deposit? Well, so again, we're going to look for balance. So let's call B equal to balance this time, just because you can use a different letter. All right, so what are we going to say? After making a deposit of $300, he finds his account still overdrawn. So we're going to say the balance plus $300 is equal to overdrawn. Well, that means it's a negative 70. And so that's what we have for our equation. Now, what do we have to do? Well, we have to subtract 300 from both sides. So the balance, now a negative 300 minus 70 more, well, that's going to give me a negative $370. So that's what we're saying his balance was before he made that deposit. Now, does that make sense? Well, let's plug in negative 370 plus 300, and we're saying that's supposed to be negative 70. Well, 370 minus 300 is 70, and the larger sign was negative, so negative 70 equals negative 70. That checks out. All right, next one. 6 less than 3 times a certain number is 21. The unknown number is what? Well, let's call X is our unknown. Okay. So let's write this just as we go down here. 6 less than 3 times a certain number. Well, so we're going to have 3 times a certain number, 3 times X, and we want 6 less than that. So minus 6, and that is 21. Okay. So if we look at this, 6 less than 3 times a certain number is 21. Now we just have to solve it. So let's first, remember we're doing things in backwards order now. We're going to do adding and subtracting first and then dividing and multiplying. So we'll add 6. So 3x equals 27. Now we can divide by 3. And so x is equal to what? Well, 27 divided by 3 is 9. Okay, so that's what we're saying our number is. So does that number make sense? 3 times 9 minus 6 equals 21. Well, 3 times 9 is 27 minus 6. Well, 7 minus 6 is 1, 2, 21 equals 21. Does check out. All right, so here we have the quotient of two integers. And they say that is equal to 3. One of the integers is negative 7. Find the other integer. Well, when we're doing these, we're going to set this up and say x is one integer. And we're going to say that is the one that goes on top. And then we're going to divide by the other integer, which was negative 7. And that is 3. Okay. Well, now how do we solve this? Well, we have to get rid of that negative 7 down here. So it's divided here. So that means we have to multiply by negative 7. If we want, we can put it in parentheses. And we'll multiply it by a negative 7 here. So that cancels out. We get x equals, well, 3 times 7 is 21, and it's a negative, so it's going to be negative 21. Now, does that make sense? Well, does negative 21 divided by a negative 7 equal 3? Well, negative divided by negative becomes positive. 21 divided by 7 is 3. And so it does work. So if you think about it, how many times does 7 go into 21? Well, it goes in 3 times. That's 21. Subtract, and we get 0. Okay, so that would be the correct value for the other integer. All right, I'll pause there and come back in a little bit.